Hey everybody, welcome to the webinar on the build of our next high-performance home. This is going to be in Atlanta, Georgia. I'm Corbett, if you don't know me from the rest of the Home Performance channel videos. I used to be a musician, now I do home performance testing, and I basically am an expert in controlling invisible dynamics inside of residential buildings. So this is all about the building that I'm going to build for my family. So if you want to see what choices I would make if I was to build a regular house, not like this, you can see it in this webinar series. Now this is the Tiny Lab. If you're not familiar with the Tiny Lab, it is the world's highest performance tiny house on wheels, as you can see from the title here. We call it the Tesla of tiny homes. It traveled 13,000 miles through the US. We did tons of presentations, hundreds of them, had 7,000 people through the house in open house tours, and we really tried to show people what home performance is like. Instead of just talking about it, which is what we're going to do in this webinar, we really had people into our home, closed the door, and said, what do you feel like? What does it smell like? What does it sound like? And that experience was very important to us. We felt like we got the bug for getting this out to normal people everywhere. Normal people being what I like to think of myself as I used to be before I learned so much, especially lately. Now, in order to get performance under control at all, you need to say the mantra, which is the home is a system, and you say it to yourself every day. This is brainwashing yourself, which is good because everyone else who's trying to sell you things is trying to brainwash you the other way, which is that your home is just a haphazard collection of belongings that happen to be in the same room at the same time. Not true. Everything interrelates and interdepends on every other thing. And so what my house that I've got here is a roof and walls and a balcony and a front door and a water heater and a heating system and a cooling system. It's a system of interrelating, invisible, dynamically controlled forces that I need to pay attention to. So in order to get this house under control, we're just going to blast through this 4, 3, 2, 1 breakdown. This is really important to come back through every single time you're thinking about any project that has to do with home improvement, finding what problems are in a home or pinpointing the source of problems, or building a new home. We've got 4 elements to home performance, 3 recommendations to make on this home, the 2 systems of this home that we're going to talk about in this webinar series, and the 1 goal of doing anything that I'm talking about in this webinar. So the 4 elements, we would always start with heat flow. People know they need good windows, they need insulation, they need an efficient heating system and cooling system. All that stuff is good, but it is not the whole recipe. That's like saying chocolate chip cookies are made out of baking soda, a pan, and an oven. That's totally ridiculous. You need the main ingredients, which are above. Airflow and pressure being one of these main ingredients. And this is something that's very important in high performance building. You really need to pay attention to this. And the people who are supposed to pay attention to this are nowhere to be seen. Because you would think that HVAC is the field that would really know about this, but most of the time you're not telling your HVAC guy about the airtightness of your house. You're not telling your HVAC guy exactly what the SHGC ratings on your windows are. They have to guess at a lot of that stuff, and so they're not in the know about the airflow and pressure. You need to have somebody who's thinking though about the whole system, which can be the HVAC professional, to be sure, but more often it's going to be somebody who's a home performance specialist. Moisture is something that I am crazy about now that we have toured with the Tiny Lab. I'll tell you about that in a few minutes, but the moisture issue is a big one for me. I think that needs to be taken very seriously, or else. That's like the end of the world to me. And air quality being the number 1 issue. And HOMEChem being the recent study. If you watch some of the videos on our channel about HOMEChem, that's the House Observations of Microbial and Environmental Chemistry experiment that was happening in Texas just a month or 2 ago. That taught us a lot about air quality. Air quality is so much deeper than I thought it was even 3 months ago. Now, just to remind everybody, energy efficiency is not what we're talking about in this video or in any video that I ever make. I don't care. Not many people do. We say that we want it, but it's generally a secondary effect. What we really are after is the 1 goal, which I'll get to in a minute. 3 recommendations I'm going to make on this home to make sure that I get the performance I'm looking for is air sealing. Air sealing everywhere. That includes the ducts. All my ducts are going to be inside the enclosure, if you know what that means. But that doesn't mean that they're not going to be sealed. They are going to be sealed because ducts are plumbing for air. Everything should be air sealed. The walls, the ceiling, the floor, etc. Insulation must be installed. It must be good insulation. And there's almost every kind of insulation is good. I will say that there are a few exceptions, and I personally have experience with at least 2 of them that are not good to work with. But it also needs to be installed perfectly, and that takes time, and it takes attention. And you need to have things like exterior insulation if you don't want to pay too much attention about the cavity insulation, etc. And lastly, HVAC and mechanicals that are really sophisticated and will work and do what you ask them to do. The 2 main systems that we're going to pay attention to in this house that we're going to build in Atlanta are, number 1, the enclosure. That's the air seal and insulation layer, the weather barrier, if you will. That's the skin of the house. And then the circulatory system of the house is the engines, anything that moves around heat or moves air, either within the house or between the house and outside. Now, the one goal for doing all of this stuff that I'm going to go into in these webinars, and there's going to be 4 in this series about my upcoming build for my family, is not energy efficiency, not sustainability, not even comfort. Because just to remind everyone, if I sit a married couple down at their table and I say, I'm going to make you both more comfortable, I am lying to one of them. Because what we're really going to do is make her more comfortable. They both have different ideas of what temperature is the ideal temperature, guaranteed. Never met a married couple that would agree on that. What you're getting is control. I want to be able to have this house do exactly what I want it to do, no matter what I want it to do. So I want to build something that has a bunch of little gauges and switches and buttons and dials on it so that I can make it play a circus song if I wanted to, or I can make it play a sonata, or I can, anything like that. And as a musician in my former career, I'm going to make music analogies. But this is the thing. If you control heat flow, control airflow and pressure, control moisture, control air quality in this house that I'm about to build for my family, then we win. But the only way to prove you have control is to test. We will be doing that, so tune in on the Home Performance YouTube channel for all of that testing. Here's the goals that we had as far as lifestyle goes. And I'm just going to kind of elaborate on these. This is my little family. This is my beautiful wife, who is a filmmaker and the co-host with me of Home Diagnosis, which I'm going to talk about at the end of this webinar. My 2 daughters. We're happy. I want to make sure that we stay that way and healthy. My kids have really never been sick. It's pretty amazing. And we've lived in that 200 square foot house that you can see behind us for 2.5 years with 2 cats. So we do not want our next house to be too small. Frankly, you may have heard me say this, I am not a tiny house advocate. I think it's very dangerous. In general, the air quality inside tiny houses is going to be way worse than the air quality inside normal size houses for several reasons I will not get into here. Suffice it to say that I just don't want a small house anymore. It's not sustainable for a family who's going to be relaxed and happy and stress-free. But we also don't want it to be bloated. I don't want a McMansion. I don't want a place that's going to take me a million years to clean, because there are some certain benefits to having a small house that we want to retain. We wanted to have a music and dance studio. This is because Grace is a dancer, former dancer. I am a former musician. That means former means professional. We still do play music and dance, but we want to be able to have dance parties in our house. And my buddy Blake Reed had a disco ball in his kitchen. We're going to have a disco ball in our dance studio. We want it to be easy to maintain and modify. That is the house. I want to make sure that I don't, for example, bury anything under concrete that I would later need to get to. So that's going to lead to the development of the crawl space that you're going to see. We want to be able to host parties and guests. I want to, for example, at the end of a party, Grace tends to, her favorite thing is cooking a 4-course meal for 12 people. Guess who does the dishes? But I don't cook, so that's a good trade. But when I do the dishes, I want to be able to face into the party, which means I need to have an island with the sink in the island. And so we thought about all these things that we want to be able to do with this house and the way we want to feel and the way we want to operate it. We obviously have a guest room. We also have the studio, which can double as a guest room. We also have the tiny lab, which can double as a guest room. So we've got lots of room for people. We also have about 2.5 acres that can host lots and lots of people if they wanted to come and camp out, which is only comfortable in certain seasons, and we know that from experience. We want to have outside spaces. Outside spaces does not mean just grass and outside. If you have never owned land in a place that has a lot of mosquitoes, you don't know how important this is. I need to have screened enclosures, and I need to have places where we're safe from the insects that are all over the place, because putting on insect repellent every single time you go outside is totally exhausting. And we are not afraid to be super unconventional, clearly, and we want it to be a unique house. So I'm not super concerned about anything that people would say, oh, well, you need to have that. We're probably going to replicate, for example, in the bathrooms, we'll have foot pedals to actuate the water faucet. So performance goals to follow upon the heels of the lifestyle goals are, number one, we are on a road that has a 35-mile-an-hour speed limit, but it is a pretty busy road. So we are set back from the road about 150 feet. That being said, big trucks do come by. I want to protect the house from the road noise. We also are located near the busiest airport in the world. And so, yeah, you might be able to hear some planes in the living room where I'm talking to you from, which is not my house, but you'll be able to hear some planes in the background unless you take special care to make sure that the place is soundproofed. The main house also needs to be protected from the noise, which is coming from the studio. When you're in the studio, it's going to be called music. But when you're not in the studio, you don't want to be listening to it, it's noise. So you want to make sure that there is all of that stuff taken care of. Also, everything in my house, including the foundation, including the roof, etc., needs to be protected from water leakage. Two main points here. Number one, we found out that on a ductless mini split, when you have shoulder seasons are like spring and fall. And what you'll have happen is in the nighttime in the morning, it's cold outside. You're in heating mode. And then in the daytime, from around noon to about 6 o'clock, you'll be in cooling mode because it's a little warmer outside than you want it to be inside. And so you use air conditioning. On a ductless mini split, you can't do that because what'll happen is you dump. We had one day where we had it in cooling mode. And of course, the coil is all wet when that happens because it's drawing moisture out of the air. And then it got a little cold and we wanted to warm it up in the house. So we kicked it into heating mode and literally within 20 seconds, every surface in my house was dripping wet with water because all of the water that had been in the coil got reactivated into the house. I can't have that. And also I can't have what happened in Phoenix, which is that the water bag inside of our tiny lab leaked 25 gallons of water into the floor. That was a total disaster. And so now anytime any water like spills on the floor, I'm a total wreck. And I get super stressed out. I try not to yell. That's my new thing, is especially with a 2-year-old and a baby as well. I'm trying to be a very calm person, but water is one of those things that really drives me crazy. Temperature and humidity need to be consistent in every room of the house, including the crawl spaces, and from moment to moment. I want it to be the same temperature over the entire course of a day. And the same humidity. I don't want things to fluctuate. And you can do all this, by the way. And the last thing is air quality is tightly controlled. I'm not joking around. Radon is an example, right? The specified action standard for radon is 4 picocuries per liter of air. That's not the action level I'm taking. I'm a dad of kids. 0 is my perfect level. I want 0. Not 1 or 2 or 3 or 4. So this means that I'm going to be a freak about implementing the steps that are going to get me there. So building the specifications upon those goals that I just enumerated are, number one, we must have an airtight building that is well insulated. I have plenty of people who comment on this channel and in my classes and say, well, building airtight is not necessary. Wrong. It is necessary. If you want to control any of the 4 elements, heat flow, airflow and pressure, moisture, and air quality, you must have airtightness first. That is a given. How airtight is up to you. You can get to 3 air changes per hour at 50. That's during the blower. So if you don't know what that means, go to another video on my channel for sure. There's lots to learn here. Well insulated means, like I said before, good insulation product installed well, and that's so important. I'm going to be installing the insulation myself and directing my friends to do this, not hiring somebody who gets paid by the total number of cavities that they fill, because if they fill it in 5 minutes or if they fill it in 5 days, they're going to get paid the same. That's not a good model. Second thing on the list is isolated studio wing. We need to have it totally air sealed and insulated away from the main house. That means it needs to have its own HVAC system, its own ventilation system, its own dehumidification system, etc. It's basically 2 houses that happen to be having a shared wall, right? Like a townhome situation. And that, by the way, includes the crawl, as you can see there. I can't have one crawl space underneath the whole house that's going to transmit sound that's going to go down from the studio into the crawl space and across the crawl space and back up into the house. I have a simple, well-planned roof and drainage system. Simple is very important. The more gables and valleys and peaks and all the stuff you've got, the more difficult it's going to be to make it work properly. No unnecessary water systems, which means I can't have a radiant heating system in my floor because I just can't stand the thought that something would leak and I would have pooling water. That literally makes me lose sleep. So yes, that's weird potentially, but it's just something that I put a limitation on myself for this next build. Efficient heating and cooling, yes, of course. And mixing, which is not a yes, of course. We're going to talk about that more in just a second. We will also need dehumidification. Most houses do, whether you know it or not. And ventilation. Again, most houses do need this, whether they know it or not. And that includes like bath fans. If you go into a bathroom and the bath fan makes a ton of noise, like a jet engine, you're not going to use it. If you're at a kitchen and you want to use the kitchen range hood, but it makes a ton of noise, you're not going to use it. I actually had a job recently where a woman said, well, they said it was going to be noisy. And I turned this thing on and I swear to God, it sounded like this. And I said, no. That's not what it's supposed to sound like. They meant it's supposed to sound like whoosh, but not that sound is bad. That means something is wrong. But she had literally been living in this house for 3 years, never using this thing because she thought, oh, that's what it's supposed to sound like. That's dumb. And we are not supposed to be building houses that do that. So here's the shape of the house. This is called a monitor barn, if you really want to know. It's a barn with a raised 2-floor central section there. So you can see here what the floor plan is. We have a large first floor here. You can see on the left. You can see here, let me get my mouse going. We would walk in the entryway here. You can go straight and go into the house past a mudroom that houses the laundry so that I can strip off disgusting clothes that I happen to have while I'm working on my 2.5 acres of land, which means pulling up brambles and wisteria and chopping down trees and things like that. Dump stuff in here. You got benches to take off your shoes, etc. Go straight into the living room and across this kind of beautiful little false wall into the kitchen with an eating area here. You could also have taken a right turn and gone through a second exterior door into the music studio. You will notice that this room has no windows. That is intentional. There will not be skylights in this room either. We want it to be blackoutable if we choose. If anybody is a musician, if you're not a musician, I'll just explain. Musicians who are recording artists spend a lot of time in studios that have no windows. So this seems perfectly acceptable to me. We also have a bathroom, full bathroom in there, and a vocal booth for my wife who does voiceover recordings. We have the master suite located on the first floor because I hope to die on this property someday, a long time from now. Not anytime soon. But we want to be able to age in place, and that means not climbing up these stairs if we don't want to. Second floor, climb up the stairs. Kiddos can choose whichever room they like. Hopefully they will share for as long as possible, and we will be able to have a guest room out of one of them. Also, like I said, this room can double as a guest room, and we have the tiny lab. Back here, through the kitchen and dining area, is the back porch, which is going to be beautiful, and it's going to be screened in and roofed with a translucent material like you see on the Building Performance Workshop that is also on my property. These 2 rooms also have balconies on them, and that goes to the quality of life stuff that we talked about just recently. So, enclosure-wise, these are the main 3 elements that are going to make this enclosure work really well. We have Georgia-Pacific force field sheathing. This sheathing is OSB. That is basically a wood panel product that's slightly heavier than plywood. It's going to be the structural sheathing for the house, meaning that it'll protect the house from shaking and all that stuff, obviously. And by the way, I know how much that stuff works because my tiny lab that's in the center picture here is sheathed with plywood on the outside and on the inside, and it does not shake at all. It feels much safer inside that house than it does inside of a normal house during a storm because this house just literally doesn't shift. That stuff is going to go all over the walls. All the above grade walls will be sheathed in this force field. The force field is not just structural sheathing, but also obviously a weather barrier, as you can see by that gray membrane. So that's going to block liquid water. It's going to block air. And when I say block, I mean be substantially airtight. We're not talking about chemistry airtight. Air is a gas molecules of O2 and N2, and that can go through things for sure. So it's going to be substantially airtight. On the roof, we're going to be using 475 High Performance Building Supply air sealing membrane that's called Adhero. And that's going to do the same job. Basically, we're going to build a monolithic thing, and then I'm going to hang the eaves of the house off of a ledger that will go outside of both of those layers. So I'm kind of excited about that detail. That's really interesting to me. The insulation is going to be rock wool. This used to be called Roxel. They recently changed their name. We're going to have cavity insulation. And in order to find out how I'm going to do all this and what levels, tune into that webinar, which is coming out soon. We're going to have cavity insulation, and we're going to have exterior insulation. Exterior insulation is going to go not on the roof because of what I'm going to talk about in the enclosure video. So stay tuned again for that. That's part 2. But definitely on the above grade walls, on the below grade walls, and under the slab. 475 is also going to be bringing the windows, which I'm very excited about. We're getting some of the best windows in the world. They're being shipped over from Europe. So that's going to be very cool, and I get to order those custom. So HVAC-wise, the other system that's so important, Mitsubishi electric heat pumps, we're going to have one ductless, which is the exact same model that I've got in the Tiny Lab. Although this room is 4 times bigger than the Tiny Lab is, it will use exactly the same heating and cooling equipment. And that doesn't even count the crawl space that's going to be connected to it, by the way. We're going to have a ducted Mitsubishi split system in the main house, and that's going to only be 1.5 tons. And again, if you want to know more about that, tune in for the 3rd video in this series. We're going to have ultra-aire dehumidifiers, one for the main house, one for the studio space. And both of those are very cool. They've got some really interesting technology on dehumidifiers that kind of, if you like thinking about heat flow and moisture transport and all that stuff, it kind of blows your mind. It's very interesting. Fantech is bringing the ventilation systems, and we're talking about ERVs, which is what is in the photo here. That's energy recovery ventilator, or you could just call it what I call it, which is an equalizing ventilator. We are also having Fantech provide the kitchen exhaust hood that is going to be quiet because it has a decoupled inline fan, basically, very far downstream from the hood itself, with a makeup air system that is going to be able to pressure equalize the house, and that's something I'm going to talk about in just a second. And also the purification system, right? So the HEPA filtration system that is going to be hooked up to the ducted system. And lastly is on-demand water heating. We've got this really interesting company that was the first one to develop a microprocessor for an on-demand heating unit. A little bit expensive on the electricity use side, but it's a really interesting technology. I'm excited about looking at it more because it is a smarter way to do it. I could potentially plumb my entire house with just one plumbing line, just cold water, and then have the hot water created where I need it, when I need it. So, in order to build high performance, you must be thinking about these enclosure HVAC conflicts. The two systems will not always agree with each other. In fact, what we are doing to this house in order to make it high performance, in order to make it controlled, is presenting fights that will happen between the two. So air tightness will lead to pressure sensitivity in the house. In the Tiny Lab, when I open my front door, which opens out, you can feel it in your ears if I do it fast enough. It depressurizes the house. And we could actually measure that, and it goes to about -50 to a -100 pressure. Pascals, by the way. That's 1 to 2 blower door tests, just opening the door for a second. So we will have something like on the order of that with this house. Of course, it's a much bigger space. We're looking at 45,000 cubic feet of air compared to, in the Tiny Lab, 2,000 cubic feet. Next thing on the list is that exhaust devices, which I will have because, of course, you need exhaust in your kitchen, you need exhaust in your bathrooms, will lead to depressurization unless I introduce pressure equalizing elements, which we will be doing, and that's the 3rd video in this series. The pressure sensitivity, by the way, there's nothing to be done about that. That is just the way that it is, period. Low load, the 3rd thing on this list, will lead to low airflows by the HVAC because essentially load is what your house is. If your house was a car, the load is the stuff that it's dragging behind it. That's all the weaknesses in the enclosure that now you need an engine in the car to be able to make up for, right? So the smaller my load is, and in this case my house has a total load of like 30,000 BTUs per hour heating and about 1.5 tons cooling. Entire house. Pretty amazing. What that leads to is that my HVAC systems will not need to run very much, or when they do run, they could run consistently but at a very low level. I'm not going to get a lot of mixing because of that. So I will need to have things like fans. I will need to be utilizing things like my ERV system to help mix the air. So all of that I need to pay special attention to. I need to pay attention to sizing my terminals on my ducts, the manual T, is for that. Or in ASHRAE, you could look at duct fitting design. But all that to say, I need to make sure that I'm introducing the right velocities around the house so that I can mix this stuff. And lastly, low load is going to lead to low dehumidification, especially in the studio where I'm going to have a ductless mini split. Ductless mini split heat pumps have a very high sensible to latent split. It's about 95% of the energy that goes into this ductless mini split coil is for lowering the temperature. 5% of it is for lowering the humidity. That means that in the tiny lab, I definitely have a dedicated dehumidifier, absolutely. And I will need that same thing in the house. So as long as you're addressing all of these, you're like preventing and predicting these challenges that will come up, these conflicts, you're safe. But these are the things you need to think of. Now, HOMEChem, again, is something that we are thinking about nonstop lately because we've been involved in this research project that was funded by the Alfred Sloan Foundation. It's the most important indoor air quality experiment ever run. And what we have found out is a whole bunch of very interesting stuff. You must have local exhaust inside. That means in your bathrooms where you're creating humidity and where you're creating potentially smells that you want to get rid of. Yeah, all that stuff is important. But also in the kitchen, including the toaster. If your toaster is not located near or under your exhaust range hood, you are getting a ton of particles ejected into your living space, and you will breathe those. It's a very interesting study, and I hope that you guys will stay tuned for that on the Home Performance YouTube channel. Excuse me. We also need to have low-emitting materials. Now, I'm going to say something that absolutely you guys are going to comment on. My house is going to be foam-free. That is because, first of all, if you doubt this, you need to go and watch my interview with Grace of Arlene Bloom, B-L-U-M. Just search it on the channel and you will find it. It's a half-an-hour interview with a biophysical chemist who has been studying things, including building foam. And one of the things that is in building foam, no matter whether it's soy-based or palm-based or just straight-up urethane spray foam, is that they have flame retardants in them because they have to in order to be sold as building insulation. Also, all furniture foam basically has flame retardants in it. These flame retardants come out, and when I said earlier substantially airtight, I meant this. You're not going to block the flame retardants, even if you have a layer of drywall. Even if you have an interior air barrier and then a layer of drywall, you're not going to block these gas molecules from coming inside. The airtightness that they're talking about when we talk to the chemists at HOMEChem is 1,000,000 times more airtight than a piece of drywall is that we're talking about. So I will not be building with foams. I'm going to get in trouble for that. I'm sure that some of you guys are going to hate on me for that, but I'm just telling you right now that aside from what is actually in the foam to make it foam, the flame retardants are something that we should really be thinking about in these super airtight buildings, especially in the case of a recent job that I went on for a client in North Carolina who said that her builder thought that more was better with spray foam. So he just literally foamed every single wall as thick as could be, the attic as thick as could be, all partition walls and interior partition floors also filled with foam. So that turns into a plastic box. It is plastic. All of it is technically plastic. So getting past that. Chemistry buffering materials. This is something that's really interesting to me. Clay-based paints being one example of this. They tend to grab oxidants, like ozone, for example, from the air and tear them apart and drop them. And they never get saturated. They never stop doing that job. So we will for sure be using clay-based something for the wall coating in the house, because that idea of using chemistry to actually moderate the chemistry in the house is very, very cool. Outside-in-wise, we need filtration. And this means, obviously, a mechanical filtration system. This filtration system does not have to be HEPA necessarily, although we will have a HEPA filtration system in the house, and it might be set up on the ERV incoming line. We're still talking with Fantech about that. But passive is the other thing. Now, you guys probably know about mechanical filtration. Yes, you pass air through a filter. A lot of the particles and things that are big enough are going to stick to the surfaces in that filtration system. But also, passive filtration means that I just need to have as many really dense surfaces so that it makes a maze for any particle or molecule to try and get inside, especially particles. I'm not a chemist, so please forgive me if I misspeak. But if a particle is coming inside and it has to come through 3.5 inches of rock wool insulation, it's not going to make it all the way. It's going to get stuck somewhere along the way because they tend to be sticky. They tend to like to stick to surfaces. So having that rock wool insulation layer is a good way. For example, the OSB, which might have a little bit of formaldehyde in the glue, and I might be worried about on the inside if I wasn't ventilating so seriously like I am going to, then I want to make sure that all that stuff gets filtered out before it hits my family's noses. Now, right now, I happen to have a 6-week distance mastermind course that is enrolling. If you're interested, please check that out. You can go to homeperformance.training, or you can go to my website, which I'm going to flash up at the end, and there's a banner at the top of my website. This is where you can learn to apply all the things that I've been talking about in this webinar to any home, and that includes existing homes, new homes, etc., your own homes. This is built for professionals, but I have people who are more hobbyists take it as well. It's a pretty good time. So that ends enrollment on August 31st. Please do check that out if you're interested. Also, make sure that you are aware that this stuff is going to be on TV soon. We're so excited. The Home Diagnosis television show, which is the first ever, can you believe it, television show about building science, will be on public television stations, hopefully in January. We're still working out the distribution channels. It's a huge bureaucratic thing that we're going through, but it's going to happen, and we're very excited about this. These are the sponsors that have made this possible to bring this show to life, and so we're very, very grateful to them. Some of them are also product partners on the house that you have just seen an overview tour of. If you want more, obviously subscribe to this channel. Like this video, comment on the video. I literally will, if you comment on this video, I will respond to you. I have my phone in my pocket and I'm pulling it out once a day and checking my YouTube comments. So please do consider us available. We are there to have a conversation about this kind of stuff with. And if you want more consulting work, obviously I have an hourly rate that I can do distance consulting if you're not in Atlanta. We also have the Building Forms podcast. If you want to know more, and take kind of my journey of being a real dummy in the beginning to being where I am now. This was my way of asking all the questions that I had of people who are amazing and having them answer them, and then I just basically made it public. So this is a free thing. You can find it on iTunes and wherever else you get podcasts. So thank you very much for paying attention to this project. Thank you for being interested in home performance. Please remember to help your friends and family understand invisible dynamics are there. They are real, they're not fake, and they also can help or hurt you. And if you're not paying attention to them, then they definitely could hurt you faster than you would expect. So please do stay tuned. We have parts 2, 3, and 4 in this webinar series coming up, and I hope that you'll tune in next time.